Bright Tuty. Every student matters.
Hello friends, welcome back. In earlier videos, we learnt about rational numbers, their properties, how to represent rational numbers on a number line, or how to get up with the rational numbers which we have between any two rational numbers. So you can find 10, 20, infinite rational numbers between any two rational numbers, and we discussed one or two methods as well to find the rational numbers between two rational numbers by finding the mean, and another method. You can watch other videos. We've discussed everything over there. So in today's video, we'll be learning about exercise 1.2. So how to solve the questions in exercise 1.2. So let's try and start with the first question of exercise 1.2. Here is the very first question of exercise 1.2, which is the last exercise of this chapter. Now we need to represent 7 by 4 on the number line. So if we need to represent, my line will not be that straight, but I'll give it a try. So we have 0 over here. Now what we discussed, we have 7 upon 4. Now we are sure that is not between 0 and 1, it will be more than 1. Now what do we need to do? We have 4 in the denominator, so we need to divide it in 4 equal parts. So that will be 1. That will be 2. That will be 3. So we've divided it into 4 equal parts. 1, 2, 3 and 4. And how can we write it down now? We'll divide it 4 parts and we'll start with 0 by 4. So this will be 1 by 4. This will be 2 by 4. This will be 3 by 4. And this will be 4 by 4, which is 1. This will be 5 by 4. This will be 6 by 4. This will be 7 by 4. So this is the number or to representation on the number line of rational number 7 by 4. Let's try out the second one. Now it's 5 by 6. Now we can see that numerator is smaller than the denominator. So whatever we will be getting, that will be between 0 and 1. Now in denominator we have 6. So we will be dividing 0 to 1 in 6 equal parts. So 2, 3, 4, 5, 6. So this is 1, 2, 3, 4, 5, 6. So this will be 1 with us. So if you'll be checking it out, so there will be 1 by 6, there will be 2 by 6, there will be 3 by 6, 4 by 6 and 5 by 6. So this is how we represent 5 by 6 on the number line. Let's move on to another question. Now we need to represent all these on the number line. I'll give you a few seconds. Give it a try and try it yourself and represent it on the number line. You can start doing your work. Meanwhile, I'll be doing something. Okay, I hope you must have done that, but I'm sure you would be doing it on the left hand side of the number 0. Why? Because they're asking about minus 2 by 11, minus 5 by 11 and minus 9 by 11. So if you moved it to the right, there will be plus 2 by 11, plus 5 by 11, plus 9 by 11. So we'll be starting up from here and we'll be going ahead with 11 equal parts. So the very first part will be minus 1 by 11. Then minus 2 by 11, minus 3 by 11, minus 4 by 11, minus 5 by 11, minus 6 by 11, minus 7 by 11, minus 8 by 11, minus 9 by 11, minus 10 by 11 and minus 1 because there will be minus 11 by 11. So if we'll talk about representing it, minus 2 by 11, this is minus 2 by 11, minus 5 by 11, this is minus 5 by 11 and this is minus 9 by 11. So what we did, if we have any of the negative rational numbers, we will be moving on to the left of 0, positive rational numbers right of 0. And we will be doing it this way. If we have denominator 11, so we will be dividing it into 11 equal parts. Now let's move on to third question. We need to write 5 rational numbers which are smaller than 2. I will give you a few seconds. Think and find it out. Right. So now I hope you must have done that. So there will be 5 rational numbers which are smaller than 2. We can write down very easily. That will be 1, 0, minus 1, minus 2, minus 3, minus 4 and so on. There are lots and lots of infinite rational numbers which you can find it out. Now, the question is that they are looking for rational numbers, but why are we writing integers? Isn't it? But all the integers are rational numbers only. So, if the number is not in the form 2 by 3, 5 by 9, 11 by 12, it doesn't mean that it is not a rational number. So every integer is a rational number. Integer, whole number, natural numbers, all are rational numbers. So less than 2, they've asked numbers smaller than 2. So to make it the easiest one, we can straight away write it down in integers. Obviously, less than 2, there will be integers only. If it will be more than 2, if they would have asked that, write 5 rational numbers which is greater than 2, then I would have written 3, 4, 5, 6, 7 and so on. Then there will be already positive integers which we would have moved on to. So this is how we can go ahead with the question. Now let's move on to next question. Now it says we need to find 10 rational numbers between minus 2 by 5 and 1 by 2. So the first thing, minus 2 by 5 and 1 by 2 is to make the denominator same. Here we go, you are correct. So we need to make the denominator same first of all, then only we can think of doing another steps which we have. So the LCM of 5 and 2 is 10. So what do? We will be multiplying it by 2 and we will be multiplying it by 5. So what do we get? We'll be getting minus 4 by 10 and 5 by 10. Now they're asking about 10 rational numbers. So if you just check that out, minus 3 by 10, minus 2 by 10, minus 1 by 10, 0 by 10, 1 by 10, 2 by 10, 3 by 10 and 4 by 10. So ultimately we will be getting 8 rational numbers between it. So what do? We'll be multiplying both of them, that means numerator and denominator, by 10. So we'll be getting minus 40 upon 100 and 50 upon 100. Now you can start writing it down with any of it. So that will be minus 39 upon 100, minus 38 upon 100, minus 37 upon 100 till 47 upon 100, 48 upon 100, 49 upon 100. So now we have more than 10 rational numbers. You can write any of it. So without even thinking what we can do, we can make the denominator same and we can multiply numerator and denominator by 10 so that we don't have to count it again and again, and we can simply find out the answer which we have, which we wanted to go ahead with. Now let's move on to fifth question. Find 5 rational numbers between 2 by 3 and 4 by 5. I'll give you a few seconds. Be with pen and paper. Think what do we do first. So first step will be, yes, you're correct, we'll be taking the LCM of 2 by 3 and 5. That will be 15. So we'll be multiplying it by 5 and we'll be multiplying it by 3 so that we can get the same denominator which is 15. So we'll be getting 10 upon 15 and 12 upon 15. Now we need to find 5 rational numbers. So without even counting how many rational numbers are there in between, we'll simply multiply it by 10. So we'll be getting 100 upon 150 and we'll be getting 120 upon 150. So now the rational numbers between them will be 101 upon 150, 102 upon 150, 103 upon 150, 104 upon 150, 105 upon 150. It's not sure that you need to write only these 5 from 101 to 150 till 119 upon 150. You can write any 5 rational numbers which you have. Now you can use that as well, adding both of them, dividing by 2, finding out the mean again and again, but that is a bit tedious process, so it's better if you can go ahead with that. It's a bit simpler and easier, isn't it? Yes, it is. So now let's move on to second part of fifth question. We need to find 5 rational numbers only. Now it is between minus 3 by 2 and 5 by 3. So the very first thing which we should do is, very good, that is taking LCM and making denominators same. So LCM of 2 and 3 is 6. So we'll be multiplying it by 3 and we'll be multiplying it by 2. So what do we get? Minus 9 upon 6 and 10 upon 6. Without even thinking, we can straight away multiply it by 10, or if we'll just check this out, you'll be getting 5 rational numbers easily. But if you need to multiply it by 10, then only would be getting the same answer. So we can write it down: minus 8 by 6, minus 7 by 6, minus 5 by 6, minus 4 by 6, minus 3 by 6, minus 2 by 6 and so on. Or we can multiply it by 10 and we can write any 5 numbers between this. So we can write 1 by 60, 2 by 60, 3 by 60, 4 by 60, 5 by 60. So you can get infinite numbers between two rational numbers. So you can use any of it. Let's move on to the third part. Now we need to find down the rational numbers, 5 rational numbers between 1 by 4 and 1 by 2. By doing the same thing, we'll be multiplying it by 1 and we'll be multiplying these two by 2. So we'll be getting 1 by 4 and 2 by 4. So multiplying both of them by 10. So we'll be getting 1 times 10 upon 4 times 10 and 2 times 10 upon 4 times 10, which will be 10 upon 40 and 20 upon 40. So you can write any 5 rational numbers between this. So let's say I've written 11 by 40, 12 by 40, 13 by 40, 14 by 40 and 15 by 40. Again you can write 16, 17, 18, 19 by 40 as well. It depends on you which rational numbers you wanted to write. Now let's move on to sixth question. Now over here it says that you need to write 5 rational numbers that is greater than minus 2. So greater than minus 2 we can write integers as well. So I think it should be minus 3, minus 4, minus 5, minus 6, minus 7. Isn't it? Easy, right? No, this is not the correct answer. Why? So let's say this is the number line and over here it is 0. So minus 1, minus 2, minus 3, minus 4, minus 5, 1, 2, 3, 4, 5. This is the number line. Now over here 5 rational numbers that are greater than minus 2. But if we'll move towards left of the number line, the numbers are decreasing. Now they're asking greater than. This is the question which is actually very easy, but students get confused in this question. So make sure that they're asking about greater than minus 2, but minus 3, minus 4, minus 5, these all are smaller than minus 2. They've asked for greater than minus 2, then these numbers which are on the right hand side of minus 2, these numbers are numbers which are greater than minus 2. So minus 1, 0, 1, 2, 3, 4. These all are rational numbers which are greater than minus 2. If they would have asked smaller than minus 2, then we would have written minus 3, minus 4, minus 5, minus 6, minus 7 and so on. So make sure that moving towards left from 0, there will be all the numbers getting smaller. To the right of 0, numbers getting bigger or greater. Let's move on to last question of this exercise which we have. We need to find 10 rational numbers between 3 by 5 and 3 by 4. So I am sure without even thinking you will be starting up with 5 and 4 LCM of it, which would be 20, which is correct. So we have discussed many questions now. So and I hope you can easily do that. So there will be 12 upon 20 and there will be 15 upon 20. So we will be multiplying both of them by 10. And the other will be 15 times 10 upon 20 times 10, which will be 120 times 200 and 150 upon 200. So I need to find 10 rational numbers. So I can start with 121 upon 200 and I can take up to 130. But again, there are so many rational numbers, you can use any of it. The answer will not be incorrect. So it's not necessary that your and your friend's answer would be same in this case. So maybe he could have think of something else. Maybe he could have multiplied by 100, multiplied and divided by 100. Then he would be getting some different answer. But it doesn't mean that his answer will be incorrect if you would not be writing it this way. So there could be infinite rational numbers. So anyone can write any of the rational numbers. It depends on the thinking. Is he multiplying it by 10, 100, 1000? So all the answers of every friend is correct if they will be moving on to or going ahead with the correct method. So this is what we have in this exercise. We have discussed almost all the questions.